Alright, another draft physics video presentation. Yes, moving the microphone. Anyway, I forgot. Drawings first. Right? Preface, counter argument to whatever the standard professional physics explanation of reality, which is nonsense. So anyway, they're basically trying to argue that there's some sort of electric and magnetic field to this thing moving the speed of light in a direction, and that somehow it's doing this crap, and this crap. It's doing something else while it's doing this. And the something else doesn't really play a role except to create some purpose for creating this, and somehow this and this creates that somewhere later. Over here somewhere, way over here. And I'm arguing that, no, the only thing the photon has is this. This is all that it has. And the question is what's a photon? I mean, is a photon that, or is a photon, a series of those lined up in some particular arrangement that creates a frequency, and that's what's being interpreted by the matter. So the matter is sitting here. The photon hits the matter, and clearly what isn't happening is some collection of this or something this. This is a big thing, many atoms across, thousands, and clearly it's not interacting with a single electron, and a single electron isn't conveying the information. So what's really happening is electrons are moving in the surface. They're constantly jiggling, say, this way and this way. And they could be jiggling this way and this way. It doesn't really matter. But anyway, the only part that's going to really matter is the way they're moving, of course. And I would say, of course. And the real point is this little bit is going to hit one in some position. And, say it was going this way, and now it's going to go that way because it hit this thing. And this one's going to hit another electron that's in some position, and this one's going to hit another electron in some position. And the idea is all of them, okay, when you add up the sequence, like it hit this one when it was, closer to the edge, and hit this one when it was further away, and they're going to end up moving in this direction, because that's the momentum, the c part, the speed of light part, okay, and they'll end up duplicating the idea of a frequency in the sense that they'll all end up going to the same place, the same way at the same time, and that's essentially like a surface moving. So the energy going in will be converted into when electrons moving, and they'll all be going in the same direction, and the surface will, the electron surface that's on the surface of both surfaces is electrons on the outside, always, will move. And when it moves, it's making the world different for the surface it's moving into. So if you understood that there was pressure always coming into things and always bouncing off of things, that everything is even like heat, everything has its thermal equilibrium. So any heat that comes into me, I'm actually generating more heat. So I'm pushing out more, but I'm also reflecting it. So I'm not a perfect example, human beings, but if I was a lizard or something, I have my equilibrium with the environment heat-wise. And if I change that, if I get hot, then I'm going to expand, so to speak, my heat profile and reflect heat quicker, sooner, more often. So the idea is if electrons move out into this field, that they will be reflecting this field, depending on where they are. So one of them, let's say, is this way, and one of them's this far, and one of them's this far, and one of them's this far. Well, the fact is the field's going to come into them coming also in staggered ways. Like each arrow that hits is going to be staggered also. And what's going to happen is the combination of the staggers is going to mean that all of them will leave, a group of them will all leave at the same time. And if that keeps happening, they're all leaving at the same time in sequence, because this is vibrating at a certain rate. You know, the movement of this one this far, and the movement of this one this far, and the movement of this one this far is a repeating cycle. And as long as the cycle keeps repeating, then the fact is there'll be a group of these things that hit the right circumstance and create the frequency back. So it's just like saying in water, you know, you're just changing the profile. You push something in the water, it moves that, all those atoms push into the other atoms, that push into the other atoms. Well, the same sort of thing is happening, except you're not pushing atoms. You're giving electrons a change in their momentum. And so you're changing where they're going to interact with the world. And when you make these changes at this specific distances, you'll end up recreating a frequency. So anyway, it's just a mechanical process that turns individual behavior into group behavior. You can think of this as a wave going in, but it really isn't, because, I mean, it is in the sense that to make photons you need more than you need more than 9 of these little arrows. You need a whole bunch of them coming in, and you might get 10, you know, you might put 100 in and you get 10 photons out, you know, kind of thing, realistically. And that's true for most surfaces. So anyway, but it's just an interaction with a bunch of electrons. Gives the electrons on one surface momentum. The momentum is transferred through the mechanism of moving some atoms, theoretically. They push out on the other side, just like they got pushed in on this side. So they got pushed in on this side by the momentum of the photons. And they're just going to push out on the other side. And that would be transmission. That would be something that's transparent. Things that aren't transparent just means that this push is so aggressive or so weak that it ends up dispersing in other directions because it has time to do that, or because there isn't enough, it's hitting it before it's rebounding, and so the system can't oscillate, and so it's pushing it essentially too far, you know, breaking it. And therefore you're not going to generate the same pattern coming out, because you've essentially broken the tension on the one surface that allows that to happen in a consistent way, you know, where you maintain the change in the frequency, the fact that it's getting hit in a cyclical manner. And you lose that cyclicalness if you penetrate the surface too aggressively. All right, that's probably enough as a premise. Stupid mic. Speaker wire's a piece of shit. Anyway. So, continuing.
At the University of Albany,
oh, poo.
we see greatness in you. There's passion and purpose, a fierce curiosity, ready to blaze big ideas.
Yes, we're just selling the idea that you're special when you're not. You're probably going to fail, and just we'll make some money on your failure.
And tackle the tough questions.
Previous video, we saw the effect of a photon, the effect that a photon has on an electron as it zips past the electron at the speed of light.
So again, that's just their story. It's a story they just made up as an explanation, and I'm just arguing it doesn't have any continuity. It doesn't make any sense. The photon is, like I said, spread over a huge area of space. Even if it was some sort of vibration, it can't have a personal relationship with one little electron. It just can't possibly be the right answer, because it's catastrophically flawed as a stream of logic. There's no logical continuity. You can't draw a rational picture of this event.
The effect that we looked at in the previous video was the changes in the magnetic field inside the photon, realizing that the magnetic field oscillations are left and right like this as the photon progresses in this direction. It's going to have an effect on the electron, and the electron is going to feel a force either up or down.
So it makes no sense, right? I mean, it's going to feel a force for no explained reason. Now, if they had some explained reason why this happens, you know, and I would argue that the reason has to do with his understanding, like he sort of was heading in the right direction when he was, you know, talking about scatter and how it has a direction to it. Well, the only thing that is significant about electrons is when you move them their profile sort of changes. That is, in the direction they're going, they become more and more visible because that's the energy they contain. So you have to kind of understand when something's moving, it's moving for a reason. It's moving because it has absorbed something, and now its profile, okay, what it has inside of it has changed. And so from looking at it this way, coming towards you, well, you can almost see that, it's huge, so to speak, okay, in the sense that there's lots to hit. There's lots coming right for you. And looking at it from the opposite direction, there's almost nothing heading right for you. It's all heading away from you. So if it was like fish, and the fish's head was a headlight, okay, a school of fish, and so the fish's head was a headlight and the tail was dark, you can sort of understand that when it's coming at you, this thing is huge, very bright. When it's going away from you, it's got, there's no light hardly coming at all. And so what's happening is these interactions are happening with the universe all the time, and clearly what's going to happen is if you just go probabilistic, what fish am I going to hit? If I threw a rock into that school of fish moving, what fish am I going to hit? Well, I'm more likely, probabilistically, to hit one of those fish than to hit one of these fish. And then if you simply extrapolate that when I hit the fish, I change its direction. So it's now going the way the rock was going. So it lost the fish swimming that way, and now it has a fish swimming another way. You can sort of get the idea. And the only thing that changes with understanding the theory is if I hit it with this thing called the B field, it has these two fields, right? They think the field is continuous, like one field is an infield and one field is an outfield, right? They think that the north end of the magnet is sending information to the south end or something, that there's an in and out. No, there's just two different fields. There's a north substance and a south substance. And the trick is when you hit this thing with a south substance, that is the wrong side of the magnet, the south side, it doesn't just, the rock, when I hit it with the rock, it doesn't knock it the way the rock was going. It knocks it perpendicular, that is, in or out. So it just changes what dimension it slides in and out of. So instead of going that way, it goes out of the board or it goes in the board, depending on whether it's a proton, and I'm hitting it with electron force, or if it's an electron, I'm hitting it with proton force. So there's a mechanism that causes this dimensional change. And it's a mechanism that really just has to do with the fact that, yes, there is no continuous field in the sense that the field is bisectable. It has to have two elements. So we're just back to 2 + 2 + 2 physics. I mean, two kinds of force, two kinds of matter, and two kinds of interaction. And the one kind stays on the same, everything stays in the same dimension. The other interaction, it involves the placing the energy in the third dimension. Which, yeah, it's a more complex concept, but if you understand it as the corners of a box, let's say, if I was to make a box, you could sort of understand that if two things were coming this way and another thing was coming this way, that it wouldn't be all that weird for them to go down that path of the box and down this side of the box. And it's the same difference than going down this way and that way, that it's just an intersection, and there's no real reason for there to be a bias, So I could argue that, if you see that, yeah. So if you had two intersecting arrows, you could argue that, yeah, they reflect off of each other, but they can also do this, right? The reflection can be a slide left or right. Well, it can also be a slide in the third dimension. It can go this way just as easy as it can go this way and this way. So once you accept that it's possible that this thing turns that way and this thing turns that way in the interaction, it's also just as plausible that, oh yeah, it could also go this way and it could go that way just as easily. So that's all this is made out of. That's the root of it. And they don't touch roots. They don't touch the foundational, fundamental functions. And again, that's obvious by the very fact that they haven't figured out that push is fundamentally reasonable, pull isn't. as a fundamental function. And the same is true for waving things. Clumps, okay, particles, can look like a wave. Soldiers can look like a wave. Bullets can look like a wave. But you can't create a wave that looks like a particle. It doesn't make any sense. A jellyfish thing, that's not elemental. You can't say the elemental function is jellyfishing. You know, blah, 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 blah. You know, no, that doesn't make any sense. That can't be elemental. All right.
Caused by the sideways oscillation of the magnetic field. In this video, we're going to see what the electric field oscillation effect will be on the electron. Notice that the electric fields will be oscillating up and down, while the magnetic fields are oscillating left and right. And there's an electron that will pass by.
So in a way, this is describing 2 + 2 physics in the sense that they're recognizing that there's 2 different functions. That's why they have an electric field and a magnetic field. They're, in a sense, recognizing that you can have an interaction where a blue thing hits a blue thing, and you can have an interaction where a blue thing hits a red thing. And the 2 interactions are different. So the magnetic field creates the dimensional change. So that's the red thing hitting the blue thing, or the blue thing hitting a red thing. That's where you get this change in dimension. That is, you throw the rock, you hit the fish, and the fish swims up. Okay. And the other reaction is you throw a rock, you hit the fish goes the way you were, and the rock comes out the way the fish was going. So one exchange is on one plane, and the other exchange can happen in the 3rd dimension. And it's essentially what they're describing in a way, by creating these 2 different fields that behave differently. But there's not 2 separate fields.
At the speed of light. We also saw that we're assuming that the light that we're using here, the photons, we're using are sunlight photons that have an E max of 1,013 volts per meter and a B max of 3.38 times 10 to the minus 6 Teslas. So that would be the maximum oscillation strength, or the intensity strength of the electric field and magnetic field inside a photon of sunlight. And we noticed on the last video that the force caused by the magnetic field oscillations is 1.62 times 10 to the minus 16 newtons on that electron, and that would be the maximum force when we have the maximum amplitude of the magnetic field oscillation.
So all they've done is turn those sideways motions into an equal sign to the momentum at the speed of light. And that's why they have 2 constants, the electric constant and the magnetic constant, that are bisections of the speed of light.
So now let's go find out what the maximum force is on the electron caused by the electric field. So the force by the electric field can be written as F is equal to the charge times the strength of the electric field, because by definition, the electric field, by definition, is equal to the force felt by a charge divided by the size of the charge. So if we then take the magnitude of this and solve for the force, we get Q times E. So this is therefore equal to the charge of the electron, which is 1.6 times 10 to the minus 19 coulombs, and multiplied times the electric field, which is going to be equal to 1,013 volts per meter, which is the same as 1,013 newtons per coulomb.
So he pointed to the Q when he said the electric field, and this, he's doing it inverse, but whatever, doesn't matter.
So 1,013 newtons per coulomb, and we calculate that, and of course that would be the force caused by the electric field, and that would be at the maximum oscillation strength. So let's find out what that is equal to. So we have 1.6 e to the...
Now again, I just point out the obvious. The only force is the momentum in a direction. It will behave as if it were a bullet or something else. There's not going to be any sideways stuff or anything else. It's the momentum is in one direction, and yes, it can be converted by the material into other directions, but the initial force is in one direction, and that's what's going to come out the other side.
19 minus times 1,013, and we get 1.62 times 10 to the minus 16 newtons. Notice that's the exact same number that we calculated when we did it for magnetic field oscillation. So we can see that the force caused by the electric field...
Yeah, notice by coincidence, but it's exactly the same numbers, so why wouldn't it be the same? I mean, it's the same frequency. It didn't change any of the variables.
Is also equal to 1.62 times 10 to the minus 16 newtons, exactly the same. That means the force of the electric field oscillation, the force on the electron caused by the electric field oscillations.
No, he's just saying the deflection, okay, like I said, I throw a rock into a school of fish. I hit a fish going that way, right? That fish is no longer in the school, so to speak. I mean, he's not providing momentum in a direction. And I've converted him, okay? And all you're saying is yeah, the fish is still swimming the same force going up. And now if I create this artificial, magnetic field thing, I can pretend that it's also going, this other direction, which it's not doing. And, let's see, I don't know how else to explain that. But yeah, obviously the fish stays going the same speed. You don't change the momentum of the fish. All you're doing is changing its direction.
And the force on the electron caused by the magnetic field oscillations are exactly the same. But what about the direction? Well, let's find out. So here we already have the direction of the force caused by the magnetic field. So let me write down F sub B so that we know that it came from the magnetic field. So now let's find out the direction of the force by the oscillation of the electric field. Since the electric field oscillations are here are up and here are down, let's take this portion right here.
So again, they just draw this is the foundational photon. They draw it a way that produces this effect in the sense that they have the two in separate dimensions, and so they're just going to pretend that somehow the fish is swimming in two dimensions at the same time, which it can't do. And so both forces would be in the same direction. Well, the truth is it's not going to move this way or this way. It's going to move that way. It's the only momentum that matters. Again, you could see in the previous video where he said, well, let's pretend the electron moves into the photon, because frankly we can't make any sense of having these two motions plus an motion in the direction it's moving. It's obviously a convolution, not a clarity here.
The electric field oscillation is downward. It can be assumed that there's an imaginary positive charge over here and an imaginary negative charge over there. That's maybe a better way of...
Yeah, right. So now we're just going to put even more complex notions into this idea that somehow the photon is creating a charged field that the photon is traveling through. And now the electron is going to be in some charge field and it's going to move in a direction because of the charge field. I mean, again, the photon is the most elemental functioning device in the universe, the smallest thing, the most discrete, and yet they're giving it all of these properties. And just pretending the matter doesn't have any at all. Pretending the electrons are just sitting there with no properties. I'm not connected to an atom. I'm not doing anything. They're turning the matter into nothing and turning the photon into everything, which is is backwards. They're turning the rock into fish and then turning the rocks into schools of fish even, when the rock is just a rock.
Looking at the electric field. So now let's place the electron in there, and we're going to use the purple color to imagine the electron. So there's the electron, and notice that the electron is going to be attracted to the positive charge and repulsed by the negative charge, even though we don't really have a charge there, but it acts as if there's a charge, which means the force felt by an electron is in the opposite.
So again, it's just a story. Let's pretend. Okay, let's just put wigs on the bears and they smoke pipes and do all this stuff. But they're dead bears. They're not. There's no reality. There's no bears wearing hats and cigars and all this crap. It's just a story.
The direction of the electric field. Since the electric field is downward here, the electron is going to feel force in the upward direction. Now, when we come up over here, and so let me draw that, so the force will be in up direction, so that the force caused by the electric field, and notice that that force is in the same direction as the direction caused by the magnetic field oscillation, so they're not working.
So let's understand. There's no evidence that the photons are polarized, that they're dipoles, there's no evidence of any of this stuff. They're creating any kind of field changes or any of this crap. It's just crap. But anyway, crap in, crap out. So they figured that much out, that they have to have the same crap go in as the crap that comes out. But the story has no continuity. It's not related to the truth. It's just a story.
In opposite direction, they're working in tandem. Both the electric field oscillation of the photon and the magnetic field oscillation cause the force in the same direction on the electron, and the magnitude of force will be exactly the same for both field oscillations. Coming over here, realizing that you can imagine that this would be a positive charge over here and a negative charge over there. So imaginary, because now we place an electron in there, and notice that the electron will be pulled towards the positive charge, repulsed by the negative charge. So the electron...
So again, I'll just point out, that thing he's working on is 1,000 times bigger, these humps, this distance, than atoms. And it's 1,000,000 times bigger than a single electron. I mean, spread over an area. 1,000,000 times bigger than an electron. This can't be the right story.
Will feel a force in the opposite direction of the electric field. So in this case, the force will be downward, just like it was for the magnetic field. So you can see that while the photon is rushing past an electron or past any charged particle, the electron is going to feel an oscillating force up and down when the photon is moving in this direction, with the field oscillating in the direction as that we've drawn on the board. And so both the electric field and the magnetic field will add half of the force that the charged particle will feel, in this case an electron, and it'll be oscillating at the same frequency.
So again, let's just understand, it's half because the two fields add up to one direction, the speed of light in a direction. And that's all they're doing. They're just converting the speed of light into two fields that don't need to exist, into motion in the two dimensions that have nothing to do with the real motion of the photon, which is this way. Okay, so they're creating just a fake mechanism to give the photon locomotion, but the only thing it has is that. The only thing the photon is doing is its clump of momentum moving in a direction, and they're creating these fake instruments happening in these other two dimensions that they're saying is causing the momentum in the third dimension, and it's just wrong.
Of the frequency of the photon. So now you can see how a photon affects an electron. As a photon rushes past an electron, as it's going by there, the electron is going to feel an oscillating force up and down according to the electric field oscillation and the magnetic field oscillation at the exact same frequency of the frequency of oscillation of the photon itself. And that's how energy is imparted from a photon to an electron. Now,
okay, and again, they have no experimental evidence, they have no hard facts, they have nothing to prove this story. It's just a story.
It could be that all the energy is imparted, and so the photon disappears and the electron absorbs the entire amount of the energy. Or if the electron or let's say that the electron is stuck inside an antenna and that photon comes by, it will cause the electron in the antenna to oscillate back and forth at the exact same frequency of the photon. So there's a very interesting relationship between how the photons...
All right, so he's taken all this confidence, right? This is like you seeing a boat comes into the harbor or something, and there's a big giant fish in the boat, right? And, I don't know, a midget. And you can come up with any story that happened out in the ocean to how the big giant fish got in a midget's boat, right? You threw a piece of dynamite into the water and blew the fish into the boat, and all kinds of stories. They're just stories. They don't have any real evidence for the story. They're just trying to, okay, let's try to figure out how it happened. I shouldn't even say fish. I should say like a wildebeest or something, right? Something bizarre, you know. There's a mountain lion in his boat. You're just coming up with a story to explain why there's a mountain lion in his boat. But you don't have any information, so almost any story will do.
affect charged particles.
Well, I shouldn't say you don't have any information. The whole point I'm making here is that you have enough information to know that what is happening. You have enough experiments to give you a pretty good idea what's happening. And what do they do when they get that information? They say wave-particle duality or some other kind of nonsense that really can't make any sense. It's not both a wave and a particle, blah, blah, blah. It's a particle that, there are a bunch of particles that can be a wave, a group behavior. But a single particle can't wave.
Because of the oscillations of the electric field and the magnetic field inside the photon. An amazing way in which energy is imparted on charged particles when photons rush by them. And that's how we know a little bit more about what a photon is.
So just a pile of crap. They have just made up the story. They're just telling you our story's right. And there's a million stories, and I'd say there's about 999,000 that are more plausible than their explanation. Okay. So enough, I believe, said. So we'll try to finish this up. Only 5 to go or so, and so forth and whatnot. So till next time.